Greetings. This is Brother Tabidi back with you. We have a very exciting day today because we're going to leave here in Los Angeles and go to Africa. And not just any place in Africa. I think we're going to go somewhere special so we can learn. Okay, so put on your seatbelts and get ready for this trip. All right, take this trip. All right. What's so exciting about the Great Pyramid of Giza is this right dead in the middle of the center of the landmass of the earth. That was not by coincidence. And you see the corners of the lateral of the pyramid. From those corners, from corners to corners on one side, it represents 365.24 cubits, which is exactly our year. So there's math all in this particular pyramid. And so today we're going to do some math in related to this particular pyramid. So take notes and let's get going. All right, before we solve this problem with the Giza Great Pyramid, what I want to do first is to do a problem from one of the oldest mathematical documents that we have, and this is the Ren Mathematical Papyrus. It was dated back 1650 BC, and this is problem 56. And in problem 56, as you can see the diagram over here to the left, it shows you a right angle pyramid, and we're basically supposed to solve. We want to find out two things. We want to find out the palms, and the palms is actually a cubit is what the measurements of meters is going to give you. But after that, you have to multiply your answer by 7 because 1 cubit equals 7 palms, and that'll tell you the palms of this particular pyramid. And there's also degrees, which we'll be doing a little bit later on. All right. So first of all, our formula says for this particular pyramid, the formula says half the base divided by the height. And so we see the base here is 360. And we know that half of 360, so is going to be 180, right? We do our math correctly. And it says divided by the height, which is 250. Okay, so that's 250, 180, and obviously 250 goes into 180 0 times. We must put a decimal here, a decimal there, and add a 0. 250 goes into 1800. We know 7 times, and actually that's 1750, if you can do the math correctly. And then that leaves 50 left over. We're going to have to add a decimal and a 0 there. 250 goes into to 500, we know 2 times. And so there goes our answer, 0.72. Now we're not done because remember, this just gives us cubits, but we want to find out what the palms is. And we have to multiply it by 7. So let's go ahead and do that. We have 0.72. Let's multiply it by 7. 7 times 2 is 14. 7 times 7 is 49, plus 1 is 50. And 7 times 0 is 0. Bring the 5 down. And we're going to count our decimal spaces. That's 2. So our decimal should be right here. So we have 5.04 palms. And that's how that's done. So we're going to use the same procedure to be able to find the palms and also the degrees of the Great Pyramid that we just visited. Okay, so let's go ahead and move on to the Great Pyramid. All right, so we're going to use the same formula we used in problem number 56 in the Ren Papyrus, and we're going to use that same information to solve this. So the formula we used was half the base divided by the height. Okay, so we know that the base is 230.33 here. And if we do that, our math correctly, we know that comes out to be 115.165. So let's go ahead and write that down. 115.165. And we're going to divide that by the height, which we see here is 146.6. And if you do that math correctly, you should get 0.7855. And then you have to multiply that by 7 in order to get the palms, because remember that 1 cubit is 7 palms. So let's go ahead and do that. Okay, let's go ahead and do that. So we have 5 times 7, we should have is 35. Then we have 5 times 7 again, 35 plus 3 is 38. And then we have 7 times 8 is 56 plus 3 is 59. 7 times 7 is 49 plus 5 is 54. And then we have 7 times 0, 0, bring the 5 down. And now we have to count back. We have 4 decimal spaces here. So we count back 1, 2, 3, and 4. And we have 5.49, which we can round that off to, yes, 5.5 palms. It would be 5.5 palms. Now, if we want to figure out the degrees down here, we're going to have to use the inverse, inverse operation of sine. And so we'll go to our calculator and do that. And then what we're going to do is we're going to put the same number here, this number right here, we're going to put that inside those parentheses. So we have 0.7855. And so let's go ahead and put this in our calculator. Oh, okay. So if we go to our calculator, we go ahead and put in information. We're going to go ahead and put in, we're going to be using, as I was saying, we're going to use sine -1, which is the inverse operation of sine. And then we're going to put those numbers we had. We have 0.7855. And you can see right here, you have 51.76, and you can round that off to, yes, 51.8, right? And as we said, yes, we have our degrees at 51.8 degrees. All right, so we have our answer. All right, everybody, hopefully you enjoy your visit. So fasten your seatbelts. We're headed back to Los Angeles, California. Welcome home. Welcome home. Hopefully everyone learned something. Thanks for tuning in. Till next time, one love.